everybody. So I just wanted to kind of go over a little bit of my background because it'll kind of play into the presentation a little bit today. So when I graduated from mines several years ago, I went to what is now Nevada Gold Mines, and I worked at their Phoenix operation. It's a multi-metal, it's copper, it's gold, it's silver, and it's a very complex operation because we have a lot of, let's call them specialty elements. But today I want to talk to you about the importance of understanding who your consumers are and what are the needs of your consumers and how that can drive value back to your mine site and your production, and how that influences you as an engineer. Yeah, I'm not that loud. So to help me out today, just know I anticipate asking you guys a lot of questions. Please interact with me. Otherwise, this is going to get a little boring. Okay. So that's my request for you guys. Yeah, I'm trying. All right. So today's this thing. Close enough? Is that better? Close enough.
Yeah, volume level. Down below, the lower, it says volume, and you can increase.
Technical fun. Okay, so what I want to talk to you guys about today is how to identify your different customers as an engineer and to think outside the box. Let's blow it up a little bit. Let's see more than just who's your direct person of contact. I want to talk about what are your customers' needs, what are the dangers of working in silos at the production level, and not understanding the full value chain of your product and what your mine is actually producing. We're going to walk through a concentrate example. We're going to walk through a doré example, and kind of get you guys thinking about more than just an engineer at the mine site level. We want to get you to think outside the box, think full value chain when we talk about this stuff. So, who can help me out? What's your customer? Just general definition, define it for me. What is a customer? Please just throw it out. It's okay. Good. Good. All right. So somebody that wants to buy your product. I want to take it one step further. It's not only somebody who wants to buy your product, but it's also a person of a specified kind that one has to deal with. That's from Webster. It's not from me. So that means it's more than just your end consumer. It can be anybody along the value chain that you interact with. So who's your customer as an engineer? When you're at the mine site, who are you dealing with? Throw some names out. Help me out. Yeah. Yeah. Come on, guys. As an engineer, you're going to have to deal with some mine ops people, right? As an engineer, once you deal with your dirt, where does it go? Mill. Yes, thank you. Once it goes to the mill, then where does it go? Refinery. Good. And who are the people that not exactly on your mine site, but have a lot of say in what you do? Bread. Yeah. Thank you. All right. So I made a fun presentation. We've got executives, you've got department managers. Not everyone is at site all the time. You've got your geologists, your engineers, your mine ops and mill ops. Those guys are your core at site people. Then you've got your next stage. You've got your refiners and your smelters and your sales team coordinating everything. And then at the very end, you've got your consumers, your jewelry producers, your tech people, your banks, everybody else. So what are your, is there a difference between customer goals and customer needs? Let's start with, what are their goals? Help me out, shout it out. Makes it funner, I promise.
Secure the commodity.
Yeah.
What they would like to have, or what they want to have.
Okay, okay. I'll get real basic. Here we go. Ready? They want your product, they want a good product, and they want it at a low cost. It's pretty simple. That covers pretty much any customer that we ever talk about, ever. That's what they want, right? But what are their needs? When you get really down specific, what do the needs look like? What are they? Anybody got anything? that, Bo?
For quality, they could be like purity requirements.
Yeah, exactly. Yeah, that's a good one. What else?
Legal source for the products.
Yeah, knowing the source. What else? Yeah, Bo.
Like with the expected production amounts. So kind of inputs in this schedule, like input cycle kind of.
Yes. Yeah. Good. Good. So in general, I came up with a list. Your quality limitations, your specifications of your product. That could range from hardness to size requirements, timeliness. When are you going to give it to them? And are they going to need it at that time? And then you've got environmental restrictions. And those can range anything from, like if we're talking about delivering products into a mill and you're running a copper flotation with a gold recovery circuit, if you're delivering cyanide soluble copper, that's going to be a problem for your gold recovery. And they're going to need to know that. But beyond that, they're only going to be able to add so much cyanide at the back end of their circuit that won't get overwhelmed by the detox. And if you overwhelm detox, then you're signing cyanide to your tail stamp, and it's a big kaboom, right? So that's what we're talking about. Lots of different things going on, lots of different needs, but all necessary for the same goal. Okay, now we're going to get into the fun part. Dangers of working in silos. So I'm going to give you guys an example. We're going to talk about what are some negative implications of what if this actually happens. So we're going to pretend like we're working out at a mine site that produces copper off a copper leach pad. A geologist finds a clay seam but doesn't say anything to anybody. Operations doesn't catch it. Everything ends up getting routed to the leach pad. Why is this a bad thing? I gave you a diagram of a leach pad in case you needed like extra background of how this thing works. You put your material here, right? You got sprinklers, your sulfur solution is going to drip through, comes into a holding pond. You do some fancy craft and you get some copper at the end. So what happens if you get clay here?
Especially clay that's driven over by the haul trucks.
Yes.
So
Let's talk about compacted clay.
It's isolated, it doesn't let like cyanide or
Exactly.
so be that.
Yes, yes. Now what happens if it's on the bottom? You've made a blind spot the whole way through the pad. Now you've got an even bigger problem. And what happens if you don't even know where you put the clay? Well, now you can't figure out where do you need to drill and break it up, or what do you need to take back off the pad. So this is a really big issue if there isn't a good form of communication between your geology group, your operations, your engineers. So it's really good to learn each other's language and be able to openly communicate what's going on. So plugging dead zone future layers. Okay, another personal favorite. An engineer fails to communicate priorities to the mining operations guys. Your foreman decides they're going to mine wherever they want. Why is that a problem?
That good sense of who you're going to blame.
Yeah. Come on, guys, this is a big one. Yeah. Right. Yeah. Yeah. I'll give you an example. When I graduated here and I started short range planning, the people I was working for didn't necessarily appreciate my opinion being a first year out of school graduate. And I made him a plan, and my mine manager took a chair and threw it across the room. He was so unhappy with what I had planned. And they were like, we're going to mine it anyway. And the reason was I had them moving the shovel 3 times in a week. And they were furious. Why are we moving the shovel this much? And it was because if we didn't, we can't make enough ore to the mill and you don't have anything else blasted. So you have to move the shovel 3 times. So in that particular case, if mine ops had not followed through and moved the shovel, we're going to run the mill out of ore. You're going to miss your production targets. And then you got corporate upset because you didn't mind what you said you were going to. And now there's a problem. So see how everything kind of comes back into play. And if you can't communicate and we can't understand what are the needs of my customer, for that, my customer was the mill, but I had to get my other customer, the mine ops, to understand and appreciate why are we doing what we're doing.
So what do you think of 30 years police plan you didn't realize that?
He just didn't like walking the shovel. It cost him money. So for him, it comes back to his goal of, this is my cost. You're impacting now my cost of being able to produce because of having to walk a shovel that I didn't want to walk. And that takes time out of production. It's expensive to do it.
So no work from the mill.
No, they were fine. They had enough material. They were fine. But basically, you've got to rework a bunch of schedules. It's going to irritate a lot of people down the line. All right, let's go through one more. Metallurgist decides they want to increase your copper head grade requirements through the mill circuit. This is a flotation circuit. Okay, has anybody ever seen these in person? They're super cool. So basically, you put everything into a liquid form, put a bunch of chemicals in a big pot, and you bubble it. You got agitators and a fan under it, and then you add a bunch of chemicals to make bubbles. And the bubbles collect all the stuff that you want to collect, plus some sulfur, and then it collects into a launder. You press it out, and you have a concentrate. And it's really cool. But what happens if they say, I no longer want a 0.1 minimum head grade, I want it to be 0.2 as my head grade? Well, as an engineer, what does that mean to you guys? Other than, oh crap.
Less reserves.
Yeah, less reserves. It's a good one. What else?
More production. More production.
Yeah. What else?
More mind blood.
Yeah. Yeah. So anything from your short range to your long range plans are going to be impacted. And this is going to be a problem because your long chain plan is going to decrease your mine life if you have to increase your head grade, right? And corporate's going to be upset because now you no longer have a 20-year mine life, you have a 15-year mine life, and they're not happy. So it makes, you have to understand, why do they want to increase from a 0.1 to a 0.2? What's driving their need for that? Is it recovery? Is it because they just want to trial something? But you guys got to talk it through a little bit. All right. Part of my background, I was a mining engineer. I pretended to be a metallurgist for a while, and that was super fun. And then I moved on and I went into marketing and sales. And so I got to see the entire value chain of our production. And I could tell you, when we mine here, we're going to make this type of concentrate and it can go to that smelter. And it mattered to be able to communicate across to everybody, right? What happens if a marketing person says, good news, everybody, I sold 42,000 tons at a 25% copper grade for the next 3 years. Based on, that's what you've been doing in the past, surely that's what you're going to do in the future. Why is that a problem? Yeah. What else? Are you guys excited? I sold all this money for you. Isn't that great?
Maybe you are not able to produce that percentage anymore.
Right.
No.
Right. Right. I didn't really ask you guys what you could make. I just told you what you're going to make. Yeah. What else? Anything else? Yeah. Yeah. So let's say we made it and the mine site can't produce that. They said, no, I can't make a 25. I can only make 12 to 20%. That's a big reduction off of what your target said. So your results are, I'm going to have to go back to the people I sold it to. I'm going to say, okay, look, I'm really sorry. The quality spec's going to have to change. And they're going to say, you know what, not a problem, but it's going to cost you. And it's going to increase your sales costs. And so now when I've increased my sales cost, all of the mine has an increased cost they've got to cover, right? So then you've also damaged your reputation. There's only so many smelters in the world, right? And if you mess with one of them, it's not like they don't communicate. They all know that you were a difficult customer to handle. So now you damaged your reputation. What does your future sales projects look like? Okay. In terms of a value chain, I wanted to kind of break it down a little bit and talk about your site value chain. This isn't new to you guys. You guys are engineers. You're extremely smart. You've got your exploration guys that go out and find it. Then we develop it. Then we have a geologist go out and map it, tell me where the stuff's at that I want. We design blast holes, we blow it up. We've got an ore control guy that sits there and says, you know what, that's ore, that's not ore. This is where everything's going. Then you've got your mine planner that's going to say, that side's going to go to leach. This side's going to go to mill. This is this week, that's next week, or next month. Your mine operations are going to pull it out of the ground and your mill operations are going to process it for you. The problem is if you can only see your blast design, you're missing a huge part of it, right? If you're only looking at ore control and saying, I'm trying to make the best value out of this polygon, but you're not incorporating, well, I need 120 feet for my shovel to sit there. Do you see why that would be a problem? It's important to understand that if you have a black box somewhere in this process, and by black box, they mean something that you don't understand, it's going to mess up your ability to perform as an engineer. Does that make sense? Okay. Now let's go to the fun part. So when does an engineer's role stop? Is it when you drop it off at the mill? So you wipe your hands of it and say, I'm done. I don't want to know anything else. Yeah. My challenge to you guys is to think beyond the mill. And my challenge to you for that reason is there's so many things past the mill that influence the need of the mill, which influences your need as an engineer, and why they all tie together and why it's so important to understand each one's needs. Okay. Does anybody know what happens after it gets processed and you make a pretty concentrate? Yeah, let's move it. Normally, when you're talking concentrates, we're going to truck it, we're going to rail it, or you're going to put it in a bulk vessel. It depends on how far away is your smelter, where are we going, right? We're going to load it. Now, when we load it, we don't just put it on the ship. There's something specific that happens at that port. We're going to sample it. Does anybody know why we sample it?
Reconciliation compare. Maybe deliberate they're gonna count it.
Yeah.
As well, so we already need some points to convert this to.
Yeah, you can. I'm going to throw something out there. We're not testing for quality. What are we testing for?
Water.
Yes. Yeah. Just shard it out, Jordy. Just throw it out.
Yeah. One idea.
So your transportable moisture limit matters. And guess what? The clay that went into the concentrate will hold water. And if you don't communicate that your clay is going through, now your concentrate is going to be too wet to ship. You're going to have to extra cost to handle it, to re-dry it. So that's an important one. So even though transportation is like a blip in our value chain, it's a big deal, right? Okay.
Is the clay comfort in the flotation process?
What? Yeah.
Is the clay comfort?
It can be entrained in your bubbles and carried through.
What the percent of clay in the concentrate?
It depends on what you fed it.
That's weird.
I know. And it depends on how well your cleaner circuit works, right? So your cleaner circuit is supposed to drip water over your bubbles without popping them and clean out what's entrained in between them so that you've got just what's on your bubble. And if that circuit's not working properly, you've got a lot more entrained material between your bubble, and it's going to mess up with the quality of your concentrate. So you've got all of these extra things coming into play that if you didn't think it all the way through, you've got a problem. Okay, so once it gets there, it's roughly 30 to 60 days to transport it from US to whatever overseas smelter we're looking at, right? They're gonna offload it. And I included pretty pictures because I love pretty pictures. Okay, when you store it and ship it, you've got a snorkeling cone. It's just basically a conveyor that comes out and dumps it into a big hold on your vessel. The vessels can hold roughly 10 to 11,000 wet metric tons at a time. If you've got a large production, you're looking at doing 4 or 5 holds on a ship at a time. If you're a small guy, you're just looking at parcel shipments, you're looking at one hold. Once it gets there, they use this pretty little clamshell. They pick it up, dump it, and now they're going to pick it up, put it in a truck. They're going to weigh it, and they're also going to sample it. This is where your big assay comes from. This is what they're depending your final sale as. So how many sets of samples are they going to take?
As much as the number of trucks.
I guess I meant how many sets. I cheated, it's on the board. It's just 3. Why do I need 3 samples? This is so fun. Okay, so I have a number You've got a number. And what happens if my number doesn't match your number? Somebody's upset, right? So we've got a certain limit that we're allowed to have a difference between. And if we're outside of that limit, we bring in that third sample and we send it to an outside lab. We call that an umpire lab. And that umpire lab, he has final say. He runs it. He's completely unbiased. Tells me what the assay is. If yours is closer, you win and I pay. Mine's closer, you pay. And if it's split, then we split the difference. So fun little details. It's important to watch those assays, and those are the ones that you want to reconcile back to what did you think you produced, where did you think it came from, and how did it end up. You also have what's called a preliminary payment going on somewhere in here. They're going to pay you roughly 60 to 80% of the value that you think is in that material. After you do your assay exchange, you guys will settle up. So we do our assay exchange, we run it to umpires, they run their smelting process. This could take a while because you're not the only delivery going into this place, right? So it depends on your, let's call it your payment terms. Most payment terms are 1 to 3 months after the month of arrival is when your quotational period is going to be. That means if I delivered this month, I'm going to use next month's price for the whole month, and that'll be the price that we use for the metals we say are in there. The reason they do that is because they're going to have time to process that material, and it shortens up that window between when they paid me to get it and when they sold it, so that they're not exposed to market changes in prices. Does that make sense? And then eventually you will get final payment after your quotational period and you decided what all the metal is. All right, let's talk about customer needs. So we talked about your transportable moisture limit, right? And I have a pretty picture of a boat flipping over. That's why it's important. If your material liquefies during the rocking of the ship, it will flip the ship over and your crew will be at risk, okay?
We don't want to pay for trickle water or falling water.
Right, what a waste of money that would be. All right, this other picture, does anybody have an idea what this one is? Something's on fire. You know why your concentrate would be on fire? Your sulfur content can be so high that it will oxidize over a certain amount of time. And when it oxidizes, it will catch fire. So your ships want to know, is your product going to end up like that? Is it going to catch fire on my ship? Because if it is, I need a different type of fire suppression system in the bulk vessels. That's a big deal, but that's going to cost you extra. But it also goes back to your geology. What type of geology did you have? What was the sulfur content? How did that come all the way through? And then run tests to see how long does it take for your concentrate to oxidize? Does this stuff need to get moved out like immediately? Or can it sit there for 30 days and not worry about it? So those are important ones. Import restriction. These are super fun. Classification of your material matters. If you're sending it into China and you think it's a copper concentrate, but you have gold in it, you should probably double check it. It is probably a gold concentrate. You are under different classification codes and different restrictions. If you're shipping under copper concentrate, you can't have any arsenic above 0.05 or different iron and different restrictions. Okay, so it's important to understand, what do you want to call the product when it gets there? And why does that matter? How does that change what you have? Certificate of origin matters because that certificate determines how much taxes you're going to pay. Some people will get really tricky and decide, you know what, I'm going to ship it to Peru. We're going to blend it with some other stuff. And then we're going to ship it with a Peruvian certificate of origin, because then we can avoid the taxes from another country. So it's super fun. There's so much fun things to know. All right. And then we've got our smelter environmental restrictions, right? Deleterious elements, there's different grade requirements, grade ranges. You get charged for everything in your product. Why does an engineer care about what you're getting charged at the end of the line? Does it impact your block model? Does it matter? Yeah. Yeah. Because at the end of the day, if you can't actually get the money for the product that you thought you were going to get because you're paying a ton of money in arsenic, isn't somebody going to be like, well, where did the arsenic come from? And why do we have so much of it? And how do I get rid of it? Wouldn't that be like an important thing to know? All right. So in my role, that was one of the biggest things that I took on was the property I was working at had an extremely complex product. We had bismuth that was the highest in the industry. It was insane. We had cadmium, we had arsenic, we had lead, we had zinc, and we were trying to call it a copper concentrate, but we couldn't keep our copper grade above 12%. So then it was like, okay, what do we do? And as a mining engineer, it was really important to figure out, can we separate the different areas of the pit? Can I run one area, make a really, really bad, nasty concentrate, and run the rest of it as really good? And we found out we can make a ton of money if we don't mix those two together and make a bad product all the time. Just make one short bad product and the rest of it pretty good. So it was really fun and it was really interesting, but we wouldn't be able to do that if we didn't understand why did it matter what the smelter received versus the mill versus what I gave them versus what the geologist said was in the rock. So super fun. Okay. We'll talk really quickly, doré, because it's really simple. So if you've got a doré coming out of your mine site, you're usually looking for cheapest transportation to your smelter. The dangers can be, and options can be, you can truck it, and you have to be careful because sometimes those trucks get held up and you will get robbed. The other one is, let's put it in a chopper and let's get it to a port and fly it out on a commercial jet. The problem with helicopters is sometimes they get crashed, and that's a big problem. There's been several times, specifically in Africa, that has happened. You got to worry about trucks being held up specifically in South America usually. So it really just, it matters how you're doing things. And then that will go back into the mine site, because if this happens and you get robbed, you have to know what was on the truck. And you have to say, this was a very good assay, and this was our accurate weight on the material so that the insurance will pay you back for it. So it's not a complete loss. Once it gets there, you're going to weigh it, you're going to sample it. You're trying to get a most homogeneous sample, so they're going to melt it. Then they're going to go through their final refining product, get silver bars, gold bars, make jewelry grain and all that good stuff. What are their customer needs? Your trucks are going to want to know, when are we picking up and how much is it? Your import restrictions are going to want to know, is there taxes involved or not? And then you've got smelter requirements. The fun thing about smelter requirements is their pay range is not on a linear scale. So it matters to an engineer to try to up your gold content, because you can get significantly higher gold payable rates. If you settle for a 75 but have a lot of copper in there that you could have taken out, now you've just decreased your payable rate, so you're losing money. Does that make sense? Okay. So how do we get to understanding what our customer needs are? I think there's three things. We need to pursue knowledge. If there's a black box that you don't understand, go figure it out. We need open dialogue. You have to be able to communicate not only with mine ops and mill ops, but your end consumers and all the way back through your community. What are you doing and how is it helping? And you have to challenge your status quo. Sometimes doing what's always been done is not helping your mine site. And there's different ways of doing things. So challenge your status quo. Ask the question, get to know your consumers, and learn your responsibilities and capacities of what you're capable of doing. Understand the core of your value chain. Take the time to be an active listener and effectively communicate your needs. And finally, cultivate customer service with the robust ideas. Challenge it, create different things. Continuous improvement is a very, very good thing, but you need to be effective communicators to be able to do that. So I had a fun time talking to you guys. Thank you very much for shouting out some answers to me. Does anybody have any questions or fun things we can talk about?
I think this presentation is very good for corporates, private companies.
Really?
Because they make the decisions.
Yeah.
Most of the times, and you just accomplish whatever they decide. Most of the times, unfortunately.
Some of the time, I have to challenge you a little bit. And in my experience, if you can present your information as an engineer, you can influence the corporate decision, right? But if you're only ever taking it from corporate down, you will miss out on a lot of different opportunities. Yeah.
Oh, there is a question in the chat.
Yes. Oh, you're welcome, Matt. What's up, Amit?
Explain the whole process of the first part of the research focus. That's my question.
Oh, my research? This has nothing to do with my research.
Yes.
Yeah.
Familiar with what Tom Stratman is doing with Rebos? They're trying to essentially write a program, which is a combination of accounting, management, and technical, with some sprinkling of AI and machine learning and stuff on data, so that if you change something in your value chain, it will show on a corporate level and the general, financial results of what is happening. I guess it would sort of dovetail into what you talked about, going back and forth, because if you tweak something here, it may really derail the whole system. Right. And it can actually, such analysis allows you to go back and forth and really see, by tweaking something here, what's the impact in downstream versus upstream. Yeah.
Well, it's been done a lot in terms of supply chain management and in terms of trying to manage a bullwhip effect of, if you don't share information across your different companies in the supply chain, you get this awkward bullwhip effect and everyone's losing money, right? So if we can copy what they're doing to try to reduce bullwhip effect, which is just open communication, be a lot more transparent about what your needs are, what are you doing, then we should be able to reduce our bullwhip effect in terms of our production as well. Yeah.
Great presentation. A couple of things that come up. You work for one of the big guys.
Yes, I did.
But if you're a mid-cap or a junior, your price taker from the Smelter Health, they accept it regardless of what the penalties are, charges. Sometimes you're delighted about it. Right. And it's always and the payments that are usually the initial payments like 30%. And then you have to wait for 3 months to get the reconciliation for that. The dynamics are different, and that had to be a really cool, where you had the ability to select smelters that you wanted to send product to, rather than smelters that would accept your product. That had to be a cool experience.
When I came up with the idea of splitting our product, and instead of having one with a really big range, have one that was really nasty, it was super hard to place that product. And there was only a few select smelters in the world that could handle it, but it meant the rest of it we could get better pricing for. And so that was worth doing. But yeah, no, my mid caps are a little bit different. And I would argue, unless you're the price setter in negotiations for smelting, treatment and refining charges, we all just follow the big leaders. And Newmont, in terms of a concentrate, we were not a leader. We were a leader in doré, but doré is different. Yeah. It's super easy. Anybody can sell a doré, as long as you can trace it back to origin.
That's cool.
Yes.
Sarah, how can you make money on 12% copper and concentrates? I would think your transportation charges would kill you. So when we design mines, we're looking at something that 25 to 35% is like a mark. Otherwise, it's expensive.
Yeah, we sold it as a gold con. Because I had multi-metals going, I could focus on gold specific zones and jack up that gold grade in the concentrate. And I didn't have to care whatever my copper con was, because my gold grade was high enough, it was covering everything.
So it's value per ton.
Yes. Yeah. Yeah. Yeah, Bill.
I had 2 questions. The first, I'm just not very familiar with it. You used Peru as an example for like mixing.
Yes.
Peru like a kind of like tax shelter almost for that? Or...
No, I wouldn't call it a tax shelter. They have a lot of concentrates coming out of Peru, and the port facility is capable of mixing. There are other options that are closer to Main port China would be Taiwan or Indonesia. Those other operations, there's different strategic locations of where you can compile the concentrates that make it the cheapest for transportation wise to get into. It happened to be most ships come from Asia, come up the coast and then go back around. So they make like this big circle. And so it was easy to have them blend there and then catch a ship back out.
Okay.
Yeah.
And then my second question was, is there kind of any like social network like equivalent for specifically like corporate communication between like all of these different groups to kind of increase that communication at all the different levels? Or is there not really any like general kind of software platform out there for that you know of?
Well, that could be what Jamal was just talking about in terms of machine learning and creating a platform. Otherwise, no, it's up to you to create your own network, develop your own relationships, and then have that open communication and dialogue. It's very much a human interaction driven activity. You got.
But there are market platforms for different commodities, right? Essentially, I guess London is good for metal, right?
Are you talking about selling your platform, or are you talking about?
No, I mean like just communication. So between like from the geologist all the way to the smelter,
okay.
Like making sure that the company is able to get all the different like requirements and all of their different like kind of users, if you will.
No, but the thing that can really help that is if you have a technical person in your sales role, because then they can communicate backwards and communicate out. But if you only have an accountant in your sales role that can't understand what you're trying to explain to them in terms of what you're capable of producing, you run a risk. I'm sorry. No, was that your, because you were changing on me here.
I was thinking a little different on the question that if there is a particular market where, you know, the smelters and producers and the final buyers would sort of swap, you know, assets. That makes sense. In a way, you produce your concentrate and take it to the market, and then perhaps the smelters or maybe some end users or buyers can actually bid on the product, send it to the smelter, and pick it up themselves instead of the other way around. You pay for the smelter. How does that market work? I mean,
Open Minerals has a platform like that where you can go on and say, I've produced this product, this is when it's available, and then everyone can bid on it and figure out where to transport it and everything goes. It's not widely used.
Okay.
It's more used for the smaller guys, the one-offs, the weird byproduct type things. The big guys want long-term commitments because then we can lock in our price and everything's kind of set. Then we can go out and get lower bids for our transportation because I can lock in transportation costs over a long-term contract. So there's benefits of having that personal network versus one-offs.
Those tolling contracts are common for like langbeinite, for potash minerals. So what you can do is the way they sell it is they sell in allotments, and they usually sell to brokers who then sell it to farming entities. And so in those cases you can do that. But each of those, you know, from a Intrepid's perspective, for example, they have to meet certain specs, industry specs, but they might have a better product than normal, so they can put that on it and try to get a premium price for the sale. And then the brokers come in and do that. I've never heard, you know, there's custom, you know, smelting, you know, groups in Mexico and Peru, but that's a tough thing. Usually small allotments.
Yeah, there's not a lot of tolling agreements that go through the concentrate world. Most of us want to sell it and then you take possession. If you're selling to a trader and you have a trader sitting in the middle, then the trader will want the metal at the end and then he can do his hedging position on the backside. So you see a lot more of that in terms of trader positions. In a couple weeks in the middle of November, we're going to bring in a trader. And what he's going to talk about is how the trading market works. So where he fits into our value chain and how he can give us value and different options of his abilities to move concentrates and those sorts of things. It'll be super fun. So next week, guys, we have somebody coming in to talk about bulk handling 101. And the reason why it's so important for engineers to understand this is because we're basically moving dirt as a living. And it's important to understand how do you design the chutes? How do you handle dirt? So it'll be super fun. She'll be here next week. And does anybody have any other questions? I hope you guys had fun because I had fun. So thank you very much. And that was it. If you want more pizza or leftover drinks, they're up there.
There's no.
Oh,
There's no.
never mind.
Yeah, you don't care, right? You want to pay.
Thanks, sir.